All right, here we are, Khan Academy practice. These are the assignments that I hope I sent you guys. I accidentally set one of them for just less than 24 hours, so I redid that. So ignore that one. You shouldn't see it. Start with the intro to partial sums, and then I think you can follow the sequence straight on down. I'm going to try to do these little videos in groups of 3. This is the first of those 3. So if I click over to I think this one, no, I want to go this one, and I want to click Intro to Partial Sums. Okay, so it's starting off by saying, if the nth partial sum of this series is given by this, what does this all mean? Well, it just means I'm going from 1 to 6. I'm adding up the first 6 terms of this. I just need to plug in 6 and go carefully. If I plug in 6 there, I get 36 minus 3 is 33 on top. Plug in 6 there, I get 216 when I cube that. Plus 4 is 220. 33 over 220, I can take out an 11, and I get 3 over 20. 3 over 20. 3 slash 20, and that is good. Okay, so let's see if we can do, oh, I'm done with that one. I'm going to go on to the next one. Sequence convergence divergence. Okay, so this is just being smart about, what goes to infinity fastest. If you know that hierarchy from my earlier video, n factorial goes zooming to infinity really fast. So this limit is 0. A lot of these are not tough. Let's do another one, see if which sequence converges to a limit to any particular fixed number. This is going to go, that's really 2/3 raised to the n. And if I'm multiplying 2/3 times 2/3 times 2/3, that's going to go to 0. This one is 3/2. That's going to blow up to infinity. And this one is going to be, well, n plus 1 factorial. So that's going to be like 10 factorial over 9 factorial, then 11 factorial over 10 factorial. So nope, that's the only one. These, both other ones diverge. Oops, what did I didn't click on that right. There we go. All right, let's see if we can do one more. What is 1 over 2 sine of n as n goes to infinity? That is just going around a cycle and it's oscillating, so that does not exist. And I'm looking for a little bit more complicated one. This is like, as n goes to infinity, this is a Bobo bot eats DC. That's going to 5, okay? So some of these are not tough. If we go on to the next one, this is geometric series, okay? This is one, they're telling us it's geometric, which makes it easier. Of course, it's then 0.75. What's the multiplier there? Well, it looks like it's 3/4, then another 3/4, then another 3/4. So that's our common ratio. The formula for that is the first term, which is 1, all over 1 minus r. Well, 1 minus 0.75 is 0.25 or 1/4. 1 divided by 1/4 is 4. You can look at the formula, do the math there. Let's do another one. This is a geometric series. If it converges, find the sum. Well, this is again that same formula. The first term, when I'm starting at 0, make sure you know if that's 1, it'll give you a different first term, but it's 0. So the first term is 3. So that's my numerator is 3, the first term. And then it's going to be 1 minus 1/2 is the multiplier. So 1 minus 1/2 is 1/2. Not worth even writing. That's going to be 6 right there, and so on. Let's go on to this last one. Oh, this is the quiz. Oh, this is the one we just did. What was that answer? That was 4. That's kind of a nice bonus for getting fun. All right. Let's jump to the next one. Oh. Let's jump to the next one. That's interesting. Well, I don't know what to do now. Okay. Let's do that quiz again. Let's go to that quiz again, see if I can start it up. All right. All right. If the following infinite geometric series converges, find its sum. Well, it looks like this is staying negative. There's a multiplier, which is going to be 2.7 over 3. You can always make a ratio. So basically 27 over 30, or if I take out a 3, that would be 9/10. So I'm multiplying it by 9/10. So negative 3 in the numerator, then divided by 1 minus 9/10, that would be 1/10. So it should be negative 30 right there. Which sequence converge to a limit as n goes to infinity? Okay, as n goes to infinity, that is above 1. Whoops. That is going to be 4 to the third to the n and 5 to the second to the n. So 25th to the n power over 64, 4 times itself 3 times. So 25 over 64 all raised to the n. So use your exponent. So that one is going to converge because 25 over 64 is less than 1. How about this one? 2 to the second is 4. 4 to the n over 3 to the n will not converge. And this one, we know this one is going to converge to 0. So just work on those. Next question. All right, this is an excellent one. So in these type of problems, when you're given the partial sum, if we had 10 of these terms, then the sum of those first 10 terms would be 10 minus 1 would be 9 over 11, okay? But what I'm going to do here is I'm going to think about this as, well, if I knew my 9th and my 10th term, I could just subtract them to find if I knew my 9th and my 10th sums, right? These are partial sums here. If I knew s of 10 and then I subtracted s of 9, right, I would get the actual term for the 10th term because I'm adding up those terms, and when I took that last 10th term and added it, I would get a new sum. What I need to do then is I need to subtract. Oops, I'm going to erase that. Let me erase that. I'm just going to subtract n, that's supposed to be a parentheses, n minus 1. Oh man, I can't do parentheses, minus 1. And then all over n minus 1 plus 1. All right. And what I'll get then when I do that subtraction with the algebra will be my formula for A. So let's see, if I do n minus 1 plus 1, that's just going to be n. And this is going to be 2. So it's really hard to do this just with this mouse pad. I'm sorry, it's like torture, but that's going to be n minus 2. Now if I add these fractions, the denominator is just going to be n times n plus 1. So I'm just going to put that down there now while I have a chance. In the denominator, it's going to be n times n plus 1. Okay, now the numerator, what's that numerator doing? Well, if I multiply n times that top, it's n squared minus n. If I multiply this times that and I FOIL those out, that's going to be n squared minus n and then minus 2. Well, this n squared minus n will cancel with this n squared minus n, and all I'm left with is a minus 2. So that top is going to be 2. If I'm talking too much, just write it out, use your algebra skills. Hopefully this will work, and if so, it's the last of our video bits. Yay. Okay, hope that went well.